This is Jeremy with Cryo Clarity, and in this video, we're going to be going over the electrophysiology of the heart, specifically an EKG reading. So this is a standard EKG reading, and we have 3 to 4 different components. Technically, we'll just go with 3 for now. The P wave, the QRS complex, and the T wave. So the P wave, the QRS complex, and the T wave. 3 different components. These are the 3 main components of an EKG. Now, whenever we do look at an EKG, there are 4 things we're looking for. 2 of them go with the atria and 2 of them go with the ventricles. And both of those things that go with each are the same. So instead of doing it like this, we're looking for depolarization and repolarization of both the atria and both the ventricle. So not both atria and both ventricles, but we are looking for the depolarization, the point of depolarization for the atria and the point of repolarization for the atria as well as the ventricles. So the 2 things that we look for the atria are the same 2 things that we look for the ventricles. Now the P wave is atrial depolarization. So the P wave actually marks off one of those things. And since we're looking for 2 things with the atria and 2 things with the ventricles, we are looking for a total of 4. But the P wave is atrial depolarization. That checks off 1. Now this QRS complex represents 2 things. And going by the process of elimination, if we had to logically imply what the QRS complex would hold, it would be atrial repolarization, because the atria have already depolarized, so they need to repolarize, and that would be correct, and ventricular depolarization. We have to depolarize before we repolarize. That's one principle here. But the other principle here is that the atria must go before the ventricles. The atria must go before the ventricles so that the atria help to completely fill the ventricles with blood. So the atria depolarize, and this atrial depolarization is atrial systole, which is correlated with stage 5 of the cardiac cycle and is active filling. And active filling occurs to make sure that the ventricles are filled up to their max potential before the ventricles actually work to inject blood. So the atria are going to contract to fill the ventricles. Then the ventricles are going to contract or depolarize to move that blood to the lungs or to the body. And now, since we have 3 of the 4 things, by process of elimination, that leaves us with ventricular repolarization. So the T wave represents ventricular repolarization. The T wave is correlated with stage 2 of the cardiac cycle. The QRS complex is associated with stage 1, and the P wave with stage 5. Now, looking a little bit further. So we have the P wave, we have the QRS complex, and we have the T wave. But we also have an ST segment, we also have a PR interval, and a QT interval. So ST segment exists here between the S and the T, right? Easy enough. So ST segment. Now what this is an elevation or depression of this segment is indicative of myocardial ischemia. Now MI typically stands for myocardial infarction. For the basis of this video, I'm using MI as myocardial ischemia. I'm just going to go ahead and write that out to avoid any confusion. Myocardial ischemia. ST segment elevation or depression is indicative of myocardial ischemia. Now, I do have this U wave here, right? So we said we had 3 primary components, but sometimes we will have a U wave. Sometimes you do get a U wave, and a U wave is still ventricular repolarization, but it is specifically of the papillary muscles. Specifically of the papillary muscles. And the papillary muscles are the muscles in the ventricles that attach to the leaflets of each respective valve, the atrioventricular valves, and they attach via chorda tendineae, tendinous structures. So the U wave represents papillary muscle repolarization, whereas the T wave is just ventricular repolarization in general. And technically papillary muscle regeneration or repolarization, is still ventricular repolarization, but a specific type. Now, aside from the ST segment, we also have a QT interval. Now, the QT interval is going to exist between the Q and the T, big shocker. And the QT interval, this is how we're going to work this out. We're going to look at what the QRS complex is used for and what the T wave is used for. So the T wave is always used for ventricular repolarization. So this is going to be ventricular repolarization. Now, the QRS complex is used for two things, either atrial repolarization or ventricular depolarization. The ventricles are cute. The ventricles are cute. That's all I'm going to say. The ventricles are cute. Because the ventricles are cute, QT, the QT interval is all about the ventricles, when they start depolarizing and when they start repolarizing. So the QT interval is about the ventricles because the ventricles are cute. Now, we also have a PR interval. Now, it would be logical to imply that the PR interval would be all about the atria, but that is not how it goes. The ventricles are cute, so they get some extra attention. And this PR interval is between the P wave, PR, and the R of the QRS complex. And the PR interval, the way in which we remember what it is party. So instead of spelling party, P-A-R-T-Y, nope, it's P-R-D. It's a party of the depolarizations. Party of the depolarizations. P-R-D. The PR interval is associated with the depolarizations. So we know that the P wave is atrial depolarization, and since this is a party of the depolarizations, it's going to be from atrial depolarization to ventricular depolarization. That is what the PR interval is, a party of the depolarizations, whereas the ventricles are cute for that QT interval. Aside from this, R. Since R we know is ventricular depolarization, thanks to this PR interval, and this being the party of the depolarizations, if R is enlarged, so if R extended not from here, but all the way up here, right? If it's enlarged on a typical EKG reading, that enlarged R wave represents enlarged ventricles. So if this is enlarged, equals enlarged ventricles. An enlarged R wave represents enlarged ventricles. Now, this kind of makes sense of the EKG. The P wave is atrial depolarization. The QRS complex is atrial repolarization with ventricular depolarization, while the T wave is ventricular repolarization. And sometimes if we have a U wave, that is papillary muscle repolarization, which typically doubles as an extension of ventricular repolarization, but it is the papillary muscles specifically. And we remember these because there are four things that we look for on an EKG reading: atrial and ventricular depolarization and repolarization. The ST segment, if it is elevated or decreased, can be indicative of myocardial ischemia. The QT interval is associated with the ventricles because the ventricles are cute. So ventricular depolarization to ventricular repolarization. And that's easy to remember because the T wave is only ventricular repolarization, and the way that we remember what the Q stands for is because the ventricles are cute. Ventricular depolarization is associated with Q of the QRS complex, and ventricular repolarization is the T wave. So the QT interval is all about the ventricles, and the PR interval is the party of the depolarizations. PAR-D. PRD. PR interval is associated with the depolarizations of both the atria and the ventricles. So the PR interval is atrial depolarization to ventricular depolarization. The P wave is only atrial depolarization, and the way in which we remember what the R is because the party of the PR interval, ventricular depolarization. So whenever we talk about the PR interval and the QT interval, the way in which we start off remembering what each is to remember that the P wave is only atrial depolarization, so we then only have to figure out if the R is ventricular depolarization or atrial repolarization. And the same goes for the QT segment, or the QT interval. The T is ventricular repolarization, so all we have to really gain clarity on is the Q. And the way in which we remember each is that the ventricles are acute, so the QT is all about the ventricles, depolarization to repolarization, and PR is the parity of the depolarizing factors of both the atria and ventricles.